Hello friends, welcome to my channel Raji CS Revision Notes. Today we'll solve a problem in DBMS. See, the problem is consider the transactions T1, T2, T3 and schedules S1 and S2. So they're given the transactions and then they're given schedules. In the schedules you have the read, write, and then for the data items for respective transactions, and they're given two schedules S1 and S2. So the question is which one of the following statements about the schedules is true. So only S1 is conflict serializable, S2 is conflict serializable, both S1 and S2 are conflict serializable, or neither S1 nor S2 is conflict serializable. So I need to know what is conflict serializable. It is a UGC NET August paper in computer science. Okay, August 2024. So let us see how to solve this problem. So first we'll write the schedules and see how to solve this problem in an easy way. To solve this problem, first we'll write the schedules. I've written the schedule separately, schedule 1. And then first what we'll do, if you see this, you'll get confused. So I'll tell you how to solve this in a simple manner. So first you take the data items. So x, y and z are the data items. So write it separately, x, y, z. Then write the set of what are the values for this. See, for x, read r1 of x, then r3 of x and w1 of x. So what are the values in x? You write the values separately. So okay, you have to write in the same order as it is present in the schedule. Okay, write in the same order as in the schedule. Similarly for y, write r3 of y, r2 of y, and then w3 of y. Similarly for z, write r2 of z, w3 of z, r1 of z, and w1 of z. So next, what you'll do, you have to find if it is conflict serializable. So conflict serializable means you have to draw the precedence graph. In the precedence graph, no cycle comes means it is a conflict serializable. So let us see. So to draw the precedence graph, first we should know whether after the which read write which follows in the transaction. Okay, see, when a conflict arises when it is having write operation. So what are the three ways which a conflict occur? That is when read write occurs, or write read occurs, or write write occurs. So these are three ways in which conflicts occur. So you have to check out whether these for the single data item and the different transactions, for different transactions, if these operations occur, then we have to check whether these operations occur. So first we will identify those patterns. Okay, so for the data element, that is the data item x, we'll see r1 and r3. So it is different transactions and you do not bother. So next, r1 and w1, this also you do not bother because it is in the same transaction, r1 w1. Now r3 and w1 means you read from the in transaction 3 and then you write in transaction 1. So these three are, so this is a conflict can occur here. Next, for y, so y similarly you find the which you have this type of pattern. Okay, see r3 r2 w3. So r2 r3 don't bother, r3 and w3 it is in the same transaction, don't bother. Next, r2 and w3. So this is a conflict, so you mark this. Next, z r2 w3. So this is a conflict, right? So mark this. Next, r2 and r1 read, no problem. Next, r2 and w1. So this is in read and write. So this also you have to mark. Next, see w3 and then r1. So same value w3 writing and then it is read by r1 transaction. So this is again it is a conflict, could be a conflict. Next, you find that w3 and w1 because you have write operation also, right? So w3 and w1 again is a conflict could occur. So mark this one also. So here you have 4 pattern which is in this form. Okay, so now your mark means next we try to draw the precedence graph. Okay, now here you draw the transactions, that is T2, T3 and T1. So these are the three transactions given, T1, T2, T3. Okay, so here first, for the first thing, see after R3 W1. Okay, so 3, next after 3 1. So how you have to mark? You have to mark from 3 to 1. Okay, after 3 1 comes, so 3 to 1. Next R2 to W3, that means from 2 to 3. So from 2 to 3 you have to draw an arc. Okay, R2 to W3. Next for the Z data item, you find that we have 4 slots. Okay, see R2 W3. So R2 to W3, R2 to W3, that is already from T2 to T3 already you have an arc, so it is there. Next W3 to R1, W3 to R1, that is from transaction 3 to transaction 1 already you have a arc, that is also there. Next 2 to 1, that is 2 to 1, from 2 next first to next 1, so from 2 to 1, so draw the arc. Next final one is W3 to W1, that is from 3 to 1, so from 3 to 1, so from 3 to 1 already you have a arc, so it's the same. So 3 to 1 you already have an arc, so this is the final precedence graph. Okay, so from this precedence graph, do you have a cycle? See, you have T3 to T1, T2 to T3 is there, but T2 to T1 only is there. It is not like a cycle, right? It is not like a cycle. It means it should be from T1 to T2 means it is a cycle, but it is T2 to T1. So there is no cycle. So here we can write as there is no cycle. No cycle exists. No cycle exists. Hence it is conflict serializable. Okay. I've written short form. Okay. No cycle exists, hence it is conflict serializable. Next for S2. So next I have written the schedules. See, these are the schedules, and then I have separated as X, Y and Z. Similar to a schedule S1, we have separated the 88 items as X, Y and Z, and then correspondingly I have written the values here. Read, write. From this pattern we have to identify the X values and write it, and we are write it in the order, same order as it is given. Okay, so I have written the X, Y and Z values. Now see, again we have to use the same method. We'll draw the precedence graph based on the whether it is write, read or write. Okay, first for the first one, see, read from 1, then write from 1, so no problem. But here to see, read from the third transaction and return the first transaction. So here you find that here the lesson can be a conflict, so mark this. Next read, no problem. Read, write, same transaction, no problem. Then read, write, different transactions, so can be conflict, mark it. Next read, no problem. Read, write, same transaction, no problem. Read, write, different transactions, so you have to mark it R2 and W1. Next R1 and W2. Okay, see, R1 and W2, reading from first transaction, writing second transaction, so R1 and W2. This one, another one, and then the third one, that is you write. See, write and write, so this is another conflict, so we have marked this one. Now we'll draw the transaction, that is precedence graph. Okay, so draw T1, T2, T3. See, here R3 of X and W1 of X, so the arc coming from R3 to W1, that is from transaction 3 to transaction 1. So as a from transaction 3 to transaction 1, draw an arc. Okay, next transaction 2 to transaction 3. transaction 2 to transaction 3. Next, they have three values. First, R1 to W2. So T1 to T2. So T1 to T2. So T1 to T2. We have done from T2. Then T2 to T1. See R2 and W1. So T2 to T1. Next, for this one, W2 to W1. That is T2 to T1. Same as this one. So transaction T2 to T1 as well. So look at the graph. See, you find that whether its cycle is coming here. See, T2 to T3, T3 to T1, then from T1 to T2. So this itself is a cycle. Also here you see T1 and T2. Here this itself forms a cycle. T1, T2 itself is form a cycle. So there are cycles, nearly 2 cycles here. So what is the answer? The answer will be cycles are formed. Okay, cycles formed. So that means what? It means it is not CS or conflict serializable. Okay, so find that S1 is conflict serializable, but S2 schedule is not conflict serializable. Okay, so only your answer is, so see the problem, your answer here is the first one only, because only S1 is conflict serializable. Okay, so this is the answer. So the rest of them is false. Okay friends, I hope this is was useful to you. Please share this with your friends who are preparing for NET exams. Also set exams are coming. So if you follow my channel, we have many videos on previous question papers only, solve problems. Please go through it, so that will be very useful to you in this exam time. And if you need any notes for paper 1 or paper 2, kindly write in the comment section and contact. Thank you.